Here we'll do another example of a composite function, this time trying to find h composite g of x. Once again, when we do composite functions, we're going to start with the first function, going from the left to the right. So we'll begin with function h. We'll write down our function h, but we're going to replace the x with a parentheses. Rather than saying x plus 5 on the bottom, we'll say parentheses plus 5 on the bottom. Now, inside that parentheses, we're going to put the next function in the chain. The second function in this chain is gx, and so we'll place this entire function gx inside that parentheses where I'm drawing the arrow. Therefore, when we do h composite g of x, we will still have the 1 on top of the fraction. However, on the bottom, inside that parentheses, we now place square root of x minus 4. We'll still have the plus 5 afterwards. And so this is our new composite function. Since there was very little simplification we could do at all, this didn't take too much work. However, the domain is going to prove a little bit more difficult. To find the domain of that composite function, we're going to start by finding the domain of gx first, because when we do a composite function, we have to first start with the second function and work our way backwards. So let's find the domain of gx first. In our gx function, we have a square root, and when we have a square root, that means the inside must be greater than or equal to 0, and so we'll say x minus 4 greater than or equal to 0. If we add 4 to both sides, we will end up with x greater than or equal to 4. If we draw a number line from this, that means everything greater than or equal to 4 will be part of the answer. Since we have greater than or equal to, this means we're going to use a closed dot and we're going to go to the right. So we'll place a closed dot at 4 and we're going to shade to the right. However, everything to the left of that 4 will not be part of the answer, and I'll place my red X's on that. So now we know the first restriction on our domain based on the gx function. However, now that we know the domain of gx, we must find the domain of our new composite function, which we have not looked at yet. So we're going to take this number line onto the next slide and now examine the new composite function. Here I've copied our number line onto the right upper side of the picture to show that 4 to infinity was our solution set so far based on gx. However, we can now look at our new composite function and find its domain, keeping in mind that anything to the left of 4 will not be part of the answer. Because our new composite function is a fraction, we have to set that denominator not equal to 0. Therefore, we'll say square root of x minus 4 plus 5 on the outside is not equal to 0. If we subtract 5 from both sides, we will now get square root of x minus 4 is not equal to negative 5. We've gotten the square root by itself. However, the x that we need is stuck inside of the square root, so we have to get rid of the square root. In order to remove a square root, we're going to take the second power on both sides. We'll place a parentheses and a second power, or square, on the left, and do the same on the right. The reason that we do this is because square root and square are inverse functions. We'll do more work on inverse functions in a future video, but for now, understand that if you take a square root and a square, which are inverse functions, they will cancel out, leaving you only what's inside. This means that we can cross out the square on the left and cross out the square root on the left and end up with just x minus 4 on the left. The second power and the root are now gone. We'll say not equal to, and on the right we'll have negative 5 to the second power, which is 25. Now all we need to do is add 4 to both sides, and we'll get x is not equal to 29. That's our second restriction on the domain. If you see a not equal to symbol, that will be an open circle on our picture, and so we will now place an open circle at 29, and that will split the domain into two pieces. Piece A will go from 4 to 29, and piece B will go from 29 to infinity. So for our domain of our new composite function, keeping in mind the limitations we placed with our gx domain, and keeping in mind the new limitation we've placed from our new composite function, we can say that piece A goes from 4 to 29, with the 29 as a parentheses and the 4 as a square bracket because it's closed. Then we'll say union 29 to infinity, and that will be our solution for this new composite function.